Chapter 25, Example 1. Is birth month related to success on the ball field? Some have suggested that children who are the older ones in their class at school naturally perform better in sports, and that these children then get more coaching and encouragement. Could that make a difference in who makes it to the professional level in sports? Let's consider the birth month of 1,478 Major League players born in 1975. We'll test whether the observed distribution of ball players' birth months shows just random fluctuations, or whether it represents a real deviation from the national pattern. We're going to start by finding the expected counts for each cell. We do this by using the expected percentage times the 1,478 people we started with. So for month 1, January, I'm going to do 1,478 times the 0.08 expected rate, and that gives us 118.24. February, since it's a shorter month, only has 7%, so we end up with 103.46 is our expected value. Since months 3 through 6, they're all 8%, we're going to fill that in with 118.24. They all have the same expected count. The next 4 months, we have 9% rates, which when we do 1,478 times 0.09, we get 133.02. So we just fill in that information, calculating it for each cell to get our counts. Now that we have our expected counts, we're ready to go on with the hypothesis. My null hypothesis will be that the distribution of baseball player birth months is the same as that of the public. And the alternative will be that the distribution of baseball players birth month is not the same as that of the public. So the hypothesis test for Chi Squared test is a bit different than what we've done before. We're not stating a parameter and then a hypothesis value. We're actually writing it out in context. It's very important for Chi Squared. We're always going to write out our hypotheses in context. I have counts of data. Each cell is a count. Baseball players 137 born in month 1, 121 born in February, and so on. And it is reasonable to consider the sample representative of all Major League Baseball players. 1,478 ball players are fewer than 10% of all those to ever have played Major League Baseball. My smallest cell count is 103.46. So all of my cell counts are at least 5. The conditions are met. I will use a Chi Squared model with n minus 1, so 12 minus 1, which is 11. The conditions are met. I will use a Chi Squared model for a Chi Squared goodness of fit test. So we're going to actually do this one by hand. Chi Squared equals 137 minus 118.24 squared over 118.24. That is our component for the first cell. We do the count we had minus the expected count squared divided by the expected count. And then we're going to repeat that for every cell. For February, 121 minus 103.46 squared over 103.46. For March, we're back up to that 118 expected count, but we had 116 births, so 116 minus 118.24 squared over 118.24. So this continues on and on and on till December, where we had 122 births minus our expected value of 133.02. We're going to square that numerator and then divide it by our expected value of 133.02. We type all that in the calculator just as it is there. Make sure you include the cells that we dotted. And you get a chi-squared statistic of 27.2079. So let's go to the table and find this now. We had n minus 1, or 12 minus 1 degrees of freedom. So we're looking at the 11 degrees of freedom row. So we're going to move until we get as close to that 27.2079 statistic. So move along the cell. I have 13.7, 14.63, keep going. I need to get as close as I can to that 27. Okay, and it looks there at about 26.76 is as close as we're getting. We're going to go up to the top and we get 0.005 roughly. It's not going to be exact because we didn't hit exactly the 27.2079, but it looks like our p-value will be about 0.005. So the p-value is roughly 0.005. So let's see how we can do this with technology real quick. I've put the observed and expected values into columns in the calculator already. And we're going to go to Statistics, Stat Tests, and we have this Chi Squared GOF, Goodness of Fit test. My observed list I titled Observed. My expected list I simply titled Expected. And then we had again 12 minus 1, or 11 degrees of freedom. And there you go, there's the results. Goodness fit, 27.1666. A little more accurate than we did by hand, but same thing. P-value is 0.004336. This technology gives us more accurate results, so it's a good idea to stick with that. But you need to understand how to find the components. My p-value of 0.005, or 0.004274 from the technology, you wouldn't put both, just put one of those, is very low, and I will reject the null hypothesis. There is evidence to suggest that the distribution of baseball player births by month is different from that of the public. Now, we can't do a confidence interval here to get the estimate. We can look at the individual residuals of each cell to get an idea of which month is the most unusual. But really, with chi-squared, that's about all we're going to be able to do.